Greetings to everyone. I am D. Hemopriya, studying final year M.Tech Information Technology in Tech Multitech Dr. Rangarajan, Dr. Saguntala Engineering College. Now I am going to explain about my project title, Effective Storing and Retrieval of Big Data and Ultimate Filter from Attacks, that is UFSA. My project comes under the domain data mining and, to be more precise, big data. Big data is defined as a database which tends to grow in large amounts by day, and we cannot handle this using usual database management techniques. So we have to implement new techniques to handle this big data database. There are many data parallel computing frameworks such as MapReduce and Hadoop to run data and reach applications, but they exhibit interest locality which only is part of a big data set. But in my project, the enhancing of this data grouping is done with big data distributed database and it uses index-based clustering of database and indexes all the clusters. It achieves anonymity with database by avoiding individual details towards traversing the data. And also it uses admin system which has research pattern rights and thus help in authentication and trust for data before updating to the main database. The main theme of the project is ultimate filter from attacks. It is used for avoiding database attacks, and the local system should have been encrypted data so that nobody can get any individual details towards the database. The main objective of this paper are enhancing performance in data grouping, reduce data retrieval time, database integrity, providing anonymity, CC searching mechanism, and to increase the level of security of the database. This section explains the related concepts to be identified and the existing systems methods that can be used in the project explanations. Overall introductions about the previous system to be discussed as follows. This is the base paper of my project titled Draw. Draw is a new data grouping aware data placement scheme for data intensive applications with interest locality. The authors of this paper are Wang et al. And it is published in June 2013. This paper explains that existing data parallel frameworks, example Hadoop or Hadoop based clouds, distribute the data using a random placement method for simplicity and load balance. However, we observe that many data intensive applications exhibit interest locality which only sweep part of a dataset. Without taking the data grouping into consideration, the random placement scheme does not perform well and is way below the efficiency of optimal data distribution. It dynamically scrutinizes data access from system log files and extracts optimal data groupings and reorganizes data layers to achieve the maximum parallelism per group subjective to load balance. The major disadvantages or limitations of this paper is it could not handle huge amount of database from distributed server locations, grouping or clustering main data from all the databases from various locations, manipulating huge databases from the clusters in database. If it does not find something, then we can only search in the main database, and this is the bottleneck problem. Data does not have any proper authentication and does have redundancy. We require selective redundancy for big data distributed database. The second paper in this literature review is Data Mining with Big Data. The authors are Wading et al. The paper represents two schemes which has two extremes of the model. In one of them, we only care about global behavior which produces a very small set of rules. Analytics architecture is not clear yet how an optimal architecture of an analytics system should be to deal with historic data and with real-time data at the same time. The Lambda architecture solves the problem of computing arbitrary functions on arbitrary data in real time by decomposing the problem into three layers. That is, the batch layer, the serving layer, and the speed layer. The limitations of this paper are, this paper only describes the details of the experimental details alone. They illustrate only the analytical analysis and did not provide any work proof about the data. The concept of a strict superset refers to the fact that the item is obtained by applying some additional operations on the subset item. The job tracker then splits the inputs file on remaining file sections that have no corresponding results in the cache items. The next paper is a reference architecture for big data solutions, introducing a model to perform predictive analytics using big data technology. The authors are Gibbing Bass. The paper is published in 2013. In this paper, it is explained that big data concern large volume, complex growing data sets with multiple autonomous sources. The fast development of networking, data storage, and the data collection capacity, big data are now rapidly expanding in all science and engineering domains, including physical, biological, and biomedical sciences. This paper represents the Hayes theorem, which characterizes the features of the big data revolution and and proposes a big data processing model from the data mining perspective. This data-driven model includes demand-driven aggregation of information sources, mining and analysis, user interest modeling, and security privacy considerations. We analyze the challenging issues in the data-driven model and also in the big data revolution. One criticism of this solution could be that it needs space to store the models. However, we show the limitations of this paper are none of the security mechanism has been discussed in this paper. Grouping of data takes much longer time. It does not include information about theoretic results that justify their approach to file grouping. The paper just compares the performance of algorithm with that of an exhaustive search approach. It also reports various characteristics of the locality metric based on the collected statistical data. The performance does not show the feasibility of the algorithm and closeness of its output to the optimal result formed by exhaustive approach. Big data is being harnessed for powerful new person level applications in many areas already. The system analysis includes existing system and the proposed system. The system analysis includes existing system and its disadvantages and proposed system and its advantages. The existing system of the paper includes existing data parallel frameworks, distribute data using random placement method for simplicity and load balance. Many data-intensive applications exhibit interest locality, which only state part of big data set and often accessed together, resulting from grouping semantics. Without taking data grouping into consideration, the random placement scheme does not perform well and is way below the efficiency of optimal data distribution. Data grouping aware is used, which extracts optimal data grouping and reorganizes data layouts to achieve the maximum parallelism for groups subjective to load balance. Drawbacks of the existing system are it could not handle huge amount of database from distributed server location. Searching is done only in main database and bottleneck problem occurs. Data does not have any proper authentication and does have improper redundancy of data, which increases the size of the database. To overcome all the disadvantages that are given in the existing system, we go for proposed system. To enhance this data grouping aware of data placements from various locations and to handle huge distributed database, we implement big data. Big data will have clustered data for most recently used data in various locations. It provides a common index for those clusters. Thus, data semantics first approaches the index for specific location and then the clusters in the desired location. From these, we can have easy and fast search for data in huge amounts. Ultimate filter from attacks, UFFA is used for grouping data and filtering any duplication of data, thus reduces redundancy and also protects from various attacks of the database. Data anonymity with unauthorized or unauthenticated presence will be perfect maintained here. Selective redundancy is done. The advantages of proposed system includes it handles clusters from huge databases using big data tables from the distributed database. For rectifying bottleneck problem, it creates indexes for cluster data so that it can search very quickly in index accordingly, searches the appropriate cluster database. It thus maintains anonymity of individuals in database. Big model inculcated for authenticated persons who can give proper approval for uploading and accessing data. Ultimate filter from attacks protects the database from attacks. Selective redundancy of data is done to increase the retrieval speed of data. This is the overall system architecture. First, the client will be requesting for data and it will be going through the indexing clusters from database and fast index based cluster searching. And the search mechanism goes to the main database, the big data distributed database network. After the subscribed data is found, it will be given through UFFA layer. It filters all the redundancy of data from the attacks that are given by the client, and the data given passes through anonymity and redundancy checks in which the personal details will be hidden from the clients. And also the hibernation technique is used for most recently used data, and it is used in the reduction of number of hits that are towards the main database. In the data flow diagram, there are three levels: level 0, level 1 and level 2. In level 0, the client will be requesting for data from the server and it will be going to the main database through the index cluster database and Hadoop map join reduce. In the level 1 of the data flow diagram, after reaching the Hadoop map join reduce client, The data will be passing through the UFA layer and it will filter all the attacks that are given by the client and the query will be reaching the database. The ECC algorithm is implemented for security, that is to filter the database from attacks. The fast index-based cluster searching is done to fast retrieval of data, and index-based cluster database is used in this regard. The level 2 of the data flow diagram, the most of the operations will be completed. The hibernation technique is used for performance enhancement and it reduces the hits towards the database. It contains the most recently used data as a backup, and it is known as a selective redundancy of data. Hadoop map join reduce maps with correct data with the client's query. Anonymity is maintained here through UFA. The use case diagram is a unified modeling language UML. It is a type of behavioral diagram defined by and created from a use case analysis. Its purpose is to present a graphical overview of the functionality provided by a system in terms of actors, their goals, that is represented as use cases, and any dependencies between those use cases. The actor client requests permission and the joint admin model provides access using client authentication process. Then the client accesses the Bigdata server and retrieves the respective data. This model is devoid of database attacks because ultimate filter from attacks filters all the attacks from attacking the server. Activity diagrams are graphical representations of workflows of stepwise activities and actions with support for choice, iteration and concurrency. Activity diagrams are constructed from a limited number of shapes connected with arrows. In this diagram, the query processing in the database using index-based clustering and UFA database filter is explained. A sequence diagram in a unified model language is a kind of iteration diagram that shows how processes operate with one another and in what order. It is a construct of a message sequence chart. The sequence diagram shows object interactions changed in time sequence. It depicts the objects and classes involved in the scenario and the sequence of messages exchanged between the objects needed to carry out the functionality of the scenario. Sequence diagrams typically, but not always, are associated with use case realizations in the logical view of the system under development. In this diagram, the data storing of the client will be requesting for the accessing the server. The server checks the authorization of the client and grants permission. After that, the client will store the data in the database. In the data retrieval, when the client requests for data, first the search will be made in the clustered indexes and then the pointer will proceed to the main database. Hibernation technique avoids the number of hits towards the database and prevents it from frequent crashes. Data response to the client will be checked for anonymity and redundancy of data by UFA and it is responded to the server. A collaboration diagram describes interactions among objects in terms of sequenced messages. Collaboration diagrams represent a combination of information taken from class, sequence and use case diagrams describing both the static structure and dynamic behavior of the system. Data storage can be done only with the help of client registration. So first the client gets registered and then searches for the respective data in the database. First the search is done in the indexes and clusters, and then if not available it is proceeded to the main database. In this diagram, the process of data retrieval is shown with respective operations such as authorization checks, filtering of attacks, anonymity reduction, and successful data retrieval and data check. During index and cluster check, if the queries are available, then there is no need to check within main database. The pointer itself will locate the data where it is available. If the data is not available, then most recently used data is checked and finally directed to the main database. Algorithms and techniques used in the project are index clustering algorithm followed for overcoming bottleneck problem. Elliptic curve cryptography ECC algorithm is used in providing ultimate filter from attacks, that is UFA. Hibernation technique is used for enhancing database performance and it reduces the hits provided in the database. Modules description. The four main modules in my project are creating server and client distributed database and admin authentication system, big data distribution and index clustering of databases, manipulation of databases using MapReducing applications, applying UFA and anonymity reduction. In this first module, we create server and authentication client systems which is having responses with each other. Huge datasets for different locations imbibed in distributed database systems are located. Creating multiple administrators in various locations and asking them to authentication for new data to be updated in the In Module 2, Big Data Distribution forms clusters. From the distributed database locations, clusters are formed with most recently viewed data and split them up in its appropriate locations. For the cluster databases, we have prepared indexes with reference to its corresponding locations. As reference to the clusters are available, easy spotting of the distribution of database locations even to the main database can be done. In this final module, it implements anonymity reduction by sending only abstract details needed. Other than any authentication person cannot have whole details of the particular issue. Technical persons under research patent rights will be a joint admin and authenticates database uploads to avoid attacks. When any detail which is already existing in its database is ready to upload, then it uses UFFA to avoid redundancy of data uploads. Screenshots. This screenshot shows the location 1 data that are being added and submitted to the main database. Such as the same process, that is the submit process. When the message is sent, it is received in all alert levels and all the client locations simultaneously. If there is any new disease is reported in any of the hospitals, then the symptoms and the details regarding the disease is reported to the main server through report new disease option. It is received as an alert level in all the hospitals. A new user is getting registered in the main distributed database server. If the search is given with a keyword, then the substantial amount of data will be displayed in the display image. Select redundancy of the distributed databases will be shown in this slide. Data display. The inserted values and the data present in the respective rack can be viewed with the help of display option. All the values present in the rack are displayed. This option is used in knowing the values that are inserted in the database. Based on these, new values are inserted. Center registration. The research center is getting registered with its IP address and port number to be stored in the database. If the center is registered, then the center already registered message will be displayed. It is unique as it is registered with the respective IP addresses. Data fetch. The particular rack values are to be known. It can be viewed with the help of fetch option. Using this, the data warehouse values can be viewed. The data with respective indexes and clusters are stored in particular rack. Data mapper. The mapper maps the database values to the respective clusters and indexes and the search keyword given by the client using MapReduce algorithm. First, the pointer goes to the index, then to the clusters, and then to the main database. This reduces the number of search hits of the database. The output of my project is the admin model implements admin's rights towards database integrity. Big database forms clusters and indexes in domains so that it uses MapReduce algorithms for retrieving data from huge distributed databases with fast and easy searching mechanism. Performance enhancement in data grouping can be achieved by implementing UFFA, and it protects the database from SQL injection attacks. It preserves anonymous details which are not related to the user and presents only the necessary information. It also handles anonymity for data sharing unauthenticated users to avoid privacy problems. These are my references that are included in the paper. Thank you.